Today in MATLAB Practical Examples, we're going to solve a problem that came in via email as a question from my blog. The user here wanted to take a line series and then be able to pick one point on it and then, as if using calipers, find the intersection of a circle centered at that point of a given radius and where it intersected the line series to the right. To do this, we made an algorithm that would find that point. Let's look at it as we increase the radius of the given circle and watch how the algorithm keeps working. We can see it's going to get to a tricky part here, but it solves it just fine. Let's look at the algorithm that we used here, first geometrically and then how we converted that over to code. You can see this is a typical configuration of our data, and what I want to find is that intersection of the red line series and the blue circle. We can see here it's highlighted in yellow the point we're going to look for. In the algorithm, the way it works is I'm going to look for all of the points that are within the given circle. We see 3 of them highlighted in yellow here. And then I'm going to take the one that is farthest to the right. That is the last one in the series. Once I've found that point, I'm going to look for the next point in the line series. And that's going to give me a line segment that we see highlighted in black here. Next, I need to take the circle. And we've got a circle and a line that are guaranteed to intersect at one point, because one is on the inside and one is on the outside as far as the line segment goes. We can solve that problem with a quadratic formula, and then we have found our point of intersection. Looking at the function here, you can see that most of the time is spent actually setting up the problem, choosing our x and y for the line series, and the center x and center y for the compass point. Our first part of algorithm is calling find last point within radius and sending it over cx and cy, that is the center. That will give me the last point that is within the circle. Once I've done that, I do a logic check real quick. That is going to say, is last in plus 1 less than or equal to the number of elements in x? It wouldn't do any good if the last point in the line series was the last one that was in the circle, because we need to look beyond that one more step to find a point that is outside. So we need to make that logical check. If there are no more points in the line series, then we'll just give an error that says ran out of line. Okay, once we have found the last point that is within the circle, then we're going to determine our line segment by saying take that x series and choose the last in through the last in plus 1 data points. So that's going to be the 2 that we need. Do that for the line segment x and the line segment y. And then we're going to take that information and pass it into another function, find intersect. And we can see that here, that we're just going to find the intersection given cx, cy, that is the center of the circle, and the line segment we're interested in. Notice I do not pass the radius in, and that's because we're using a concept called nested functions, so that these subfunctions that we're about to look at will automatically have r from the calling function. Let's now look at the find last point within radius subfunction. If we look at this, I'm going to move over a little to see the entire thing. And basically, we're passing in the center of the circle. We're finding the difference between every data point in the x series and the center point. Then we're doing the same for y. Then we're going to use the Pythagorean theorem to figure out what the distance from each of those points is to the center. And then we're just going to say, I want a flag, that is, or a 1 or a 0, if the distance that we just calculated is less than or equal to the radius of the circle. So now we'll have a vector of 1s and 0s, the length of the line series, and we're just going to look for the last point in that binary series that is true. We'll do that with the find command. And so that's going to give us the index of the last point that is within the radius. Once we've done that, now we have everything we need to go into the find intersection code. With the find intersection code, it really doesn't matter too much about how I derived the equations that we needed to find the intersection of the line segment and the circle. It's enough to know that it's just going to be the quadratic formula and that we solve it here. You can see that I set up easy to understand variables a, b, and c, and then I solve them with the quadratic formula here. And then finally, I use that value to go back into the parametric form of the line segment to find the actual x intersection. Now that we see how the subfunctions are written, we can look at the graphing part of this function. I'm going to drag down a little here. And we can see that I'm just going to clear the axes, plot the xy, the x-intersection, and the center point. I'm going to set the line width to be a little bit heavier. I don't want this axes jumping around auto-scaling, so I'm just going to set it to a fixed limit of plus and minus 6 on each axis. I want to put hold on because I'm going to actually draw the circle also. I didn't want to write circle code, so I just went to the file exchange and I picked one up that someone had already written. Since I've got a circle on there, I want my axes to be equal, and I like the grid on. Now, the final thing here is, as you remember, I was able to sweep through a bunch of values of r. Looking here at the top, this function main takes the value of r as an input. And what I've done is I took advantage of run configurations here. This has been covered in another video about run configurations, but basically this is a simple script that allows me to run the code that I have here with a click of F5 that will just call this miniature script. And so what I'm doing is I'm allowing my radius r to vary from 0 to 6, and then I'm just looping through, calling main and pausing at each step so I can see what the graphic looks like. Okay, I hope this was a useful way of understanding how I developed code to solve this practical example. Thank you.